Hello, good morning everyone. Today we will start class 9 physics work and energy chapter. This chapter is in our syllabus this time, so we are going to do work and energy chapter. Generally, what does work mean? Work means any physical or mental activity. But in physics, it does not mean that. In physics, it means that work is said to be done only when on a body force is applied and the body shows motion. That means when a force is applied on a body and a motion is produced in the body, then work is said to be done. So we can say the definition of work as when a force is applied on a body and the body moves, then the work is done. That means we can say there are two conditions necessary for work to be done. Two conditions are there. What are those two conditions? That means force must be applied and there must be motion in the body on which the force is applied. That means suppose a coolie is standing with a luggage on his head. Then is he doing a work? No. He is not doing a work. Why he is not doing a work? Because there is no motion. Although we will say, in a layman's language, we can say that he is doing a hard work. He is standing with so many bags or so much luggage. Or a laborer who carries bricks, other things, and he will simply take the bricks or the cement or sand on his head and he will stand there, then we will not say that he is doing work. But when he will take the sand or the bag or the bricks and he will show some movement, some motion, then work will be done. But at the same time, we have one more thing, that if the load he will take on his head and he will move vertically in a straight way, then what we will say, work is not done. Why we will say work is not done, that I will tell you later on, because their direction is perpendicular to the movement. That I will tell you later on. Now we will see here two conditions are necessary for work done, force and motion. That means if out of these two, one of them is missing, then work done is zero or no work is done. That means a body is there and we will apply force and it does not show motion. Suppose this is a wall. I am pushing on this wall. I am applying force on it, but this wall doesn't move. That means the work is not done. So two conditions are necessary. Force must be applied and motion must be there. Out of these two, if any one of them is missing, then work done is said to be zero. That means we can say no work is done. So we will see here that the formula for work done is equal to force into distance. If you denote work done with W and force with F and distance moved by S, so this will be the formula for work done. Work done is equal to F into S, where F denotes the force and S denotes the distance moved and W denotes the work done. Now we come to the next topic, that is SI unit of work. SI unit of work. In this part we will see work done is equal to F into S and the SI unit of force is Newton and of distance is meter. So we will write in symbol then Nm. But this Newton meter is known as joule. So we say that the SI unit of work done is Joule. The SI unit of work done is Joule. Now we have work is a scalar quantity. That means whenever we are talking about work, we mention it that the magnitude, we never say about the direction. In order to denote, in order to explain work done, we don't need to tell the direction. Therefore, work done is a scalar quantity. And work done will be said to be in opposite direction. Work done may be said to be positive, work done may be said to be negative, or work done may be zero. All these three cases we will see. Now we will see the next topic, work done against gravity. What is work done against gravity? That means when force is applied on a body and the body is lifted upward against the earth, or there is movement in the body in the vertical direction. In the vertical direction, then we say that the work is done against the gravity. So we write in this way, work done against gravity is equal to force into vertical distance moved, or you can write vertical height. So here we can say that the force, here we will write it in the form of mass into gravity, because this body is moving against the gravity. So here we will denote it F in terms of mass in gravity, and vertical distance, vertical height, we can denote it by H. Therefore, the formula comes for work done against gravity as mgh, where m means the mass of the body, g means acceleration due to gravity, and h means the height against or away from the earth in the upward direction. Next we have numericals based on this. So let us take an example. Suppose we are given whatever we have done, two formulas we have seen. Work done is equal to force into distance, and work done is equal to mass into gravity into height. So we will see now numericals. On this question is, how much work is done in moving a body? How much work is done moving a body with a force of 10 Newton by a distance of 20 meters. Suppose this is the question. The solution, how we will do? Work is equal to force into distance moved, and work force is how much? 10 Newton. Distance moved is 20 meter, so it will be 200 Newton meter, and we say it 200 Joule. This was based on the formula work done is equal to force into distance. Now another question we will take. Suppose we are given another question. How much work is done mass 10 kg through a height of 5 meter from the surface of earth. That means we are given that we have a body of mass 10 kg and I have to take a distance of 5 meter above the surface of the earth. Then solution we will write work done is equal to mgh, where m is our 10 kg. Acceleration due to gravity is not given to us, so we will take 9.8 meter per second square and height we will take 5 meters. So we will multiply, all will get 8 5 is 40 and 4 and 490 joules. This is your answer. We will start the next part. Work done by a force acting obliquely. See what we have studied earlier just now. We have seen that the work done is equal to force into displacement, and we had seen the definition that work is said to be done when a body moves. That means a motion is there, but what type of motion will be there? Will the body move in the direction of the force applied? Will the body move with some angle, or will the body move in the opposite direction? So now we will discuss about them. So first we will see, suppose that the body moves obliquely. You must have seen children, small boys and girls playing with toy. Suppose this is a toy car or something is there, and the child is trying to put a string tied to it, and then the child catches at this string at this place and he pulls the toy car. Then what happens? He is pulling in this way. He is applying force in this way, and then the toy car is moving in this direction. That means some angle is being made here. Suppose this is the direction of the movement and the force is applied in this at this place. So some angle is made because the motion is this way, and then here is certain angle. Suppose let me take the angle to be theta degree. Then here the work done formula will change. Work done is equal to F cos theta into S, where F is the force and cos theta will stand for the angle. Theta will stand for the angle degree of this, what angle is made by this force and the direction, and S is the displacement. So what we will say, the definition will change. What will happen? The definition will change for work done by force acting obliquely. That means it will be with the direction. The formula will also change. The formula will, instead of becoming this formula, we will apply this formula. So whenever you are given numericals, whenever you are given numericals to solve an exam, that means we have to check out, we have to see the question, read properly, whether some angles are there or what, and then we have to solve them in that way. So work done is equal to force into cos theta into S will be the formula for the body moving obliquely to the force applied. When that means it is not moving in a straight line, it is making certain angle, then we will use this formula. So work done by force acting obliquely we have seen. Now our next topic, work done when the force act at right angle to the direction of the motion. A right angle, that means you are showing the movement in this way. Suppose the motion is in this way, and the force is acting in this way. The case of a pulley, that time I told you, I will tell you later on. That pulley one case, suppose that pulley is there, he is strictly straight, vertical, and he is taking some luggage on his head and he is moving in this way, this direction. Now what we will see here, what is the angle made by this pulley and this ground? It is 90 degree. So in this way what will happen, work done will be F into cos 90 degree into displacement or distance moved S. And we know that the value of cos 90 is 0. So what will happen? Overall 0. So work done is equal to 0. Therefore we say that whenever a force is applied vertically making 90 degree perpendicularly, then the work done is 0. Work done is 0. Example I have told you earlier also about that pulley, about the worker. Suppose a worker is there, he has taken some bricks on his head and then he is simply standing. He is not showing motion. But if he is showing motion, then also he is going in a straight way on the ground and on his head he has taken. We will say that he is doing lots of work, but according to physics he is doing no work, zero work, because the angle here is 90 degree and then that value of cos 90 is 0. So work done according to physics will be 0. Now work done by a body moving in a circular path. The work done on a body moving in a circular path is also said to be 0. Why? Because see, whenever a body is moving in a circular path, then a centripetal force is acting on the body, that is keeping the body in the circular path. It keeps the body moving in a circular path. And then the tangential force acts in this way. Suppose it is going in this way, then a force acts in this. That means it is also, at this place also 90 degree is being made. 90 degree is earth moving around the sun. Although the path, the orbit of the movement of the earth is not circular, it is elliptical, but suppose we take it is to be circular, or the satellites moving around the earth, or other planets moving around the sun, we say that all of them are doing 0 work, because here in this case what we will see, in the case of circular one, in the circular body one, we say that when a body moves in a circular path, then the centripetal force acts along the radius of the circle and it is a right angle. So here suppose we will take the center, here we are taking the center, here it is the radius and this is the centripetal force acting in this way. Then here the angle made is 90 degree, and again when we apply this formula, work done is equal to F into cos 90 into S, then it will be 0. Therefore we say this, that the work done by a body in a circular path is also, work done by a body moving in a circular path is also 0. So when a body is moving in a circular path, then the work done is 0. Now we have next topic, work done when the force acts opposite to the direction of the force. Suppose you have kicked a ball, then the ball moves. In which direction you have kicked the ball? But after some time it goes and stops. Why it stops? Because another force acts in opposite direction to the movement of the ball. That is the frictional force. The frictional force acts in a direction opposite to the movement of the ball, and therefore the ball stops. So when the body is moving and a force acts in opposite direction, then the F force becomes negative. So we have studied work done is equal to F into S. Now when force will act in opposite direction, so we write minus S. Then in that case we will write work done is equal to minus F into S. Hence what will we have? Work done is negative. Here we are seeing work done is positive. Here work done will be negative. Work done is negative. Is positive when the force acts in the direction of the motion. Work done is negative when the force acts in opposite direction. And work done is zero when it acts perpendicularly to the direction of the motion, as the case we have seen of the satellites one, our planets one, or our workers, laborers, coolie, whoever is that taking the luggage on the head and then moving in a straight path, on a straight path, and then the direction made by that coolie and the ground is 90 degrees. So in that case also the work done is zero. Positive work done by body will increase the speed. Whenever work done by a body, positive work will be done by a body, that means it will increase the speed. And when negative work will be done, it will decrease the speed. And when no work will be done, then it will show no effect. Next our it is energy part. So we have this chapter in two parts, work and energy. So one part I have completed. Now energy one we will do another day. You will study nicely, see the video, and I will send the notes also. You will have to write the notes in your copy. You have to learn them and you have to be ready for your exam. All must write the notes in your copy. In your physics copy, you must write the notes, whatever I will send. And you must learn them also. Read the chapter. Go through the pages. Some more examples are given. I have solved only 2 numericals. More numericals are given in your book. So you will practice them. Okay.